A rectangle is inscribed in a circle such that each vertex of the rectangle lies on the circumference of the circle. The diagonal of the rectangle is twice the length of the shortest side of the rectangle. The area of the rectangle is 1089 times the square root of 3 square units. What is the length in units of the diameter of the circle? First, draw a rough sketch. Label what you're given. You should recognize this as a 30, 60, 90 triangle, which would save you tons of time. You should have the side length ratios memorized, but if you don't, they are in the reference sheet embedded in Blue Book. If you didn't realize this is a special right triangle, you could solve for the missing side length using the Pythagorean theorem. S squared plus b squared equals, open parentheses, 2s, close parentheses, squared. Make sure you squared the 2 and the s, giving you 4s squared. Combine like terms by subtracting s squared on each side. This leaves you with b squared equals 3s squared. To isolate b, take the square root of each side, leaving you with b equals the square root of 3 times s. Now we know that our missing side length is s square root of 3. Now we have the length and the width of the rectangle. We're told that the area of the rectangle is 1089 times the square root of 3 square units. Set that equal to the length times the width. Multiplying that out, we get s squared times square root of 3 equals 1089 times square root of 3. Cancel the square root of 3 on each side. You can think of this as dividing by the square root of 3 on each side. This gives you s squared equals 1089. Isolate s by taking the square root of each side, giving us s equals the square root of 1089, which is perfectly 33. That's the length of the shortest side. We know the length of the longest side is 2s. That's our diagonal of our rectangle and also the diameter of the circle. 2 times 33 gives us 66. This is what it could look like in Desmos. I figured it out so that all the facts are true, but don't worry about it. You really don't have to know how to do that.